All right, continuing on with functions and graphs. In this section, we're going to figure out whether a correspondence or relation is a function, find function values, outputs, graph functions, figure out whether a graph is a function, and look at the domain and range. And then your activities, you will solve some applied problems. So a function here says is a correspondence between a first set called the domain. Think of that as your input, your x value, and a second set called the range, your output, your y value. Right? So it says that each member of the domain corresponds to exactly one member of the range. So if we're given a list of these values here and we want to figure out if this is a function, this is a function because each member of the domain corresponds to exactly one member of the range. So in other words, you don't have -6 going to 36 and also going to 9. All right, and so we talk about these relations being a correspondence between the first set called the domain, and again, just keep thinking about this. You're going to hear me call it your x values, and then your range, your y values. And so determine whether each of the following relation is a function, and then look at the domain and range. As we can see, 9, my x value, and again, even think of an input is going to do 2 different outputs. So this is not a function. All right, so this would not be a function. The domain are the first coordinates, so it would be 9 and 2. And then the range would be the second coordinates, -5, 5, and 4. All right, can look at another example and notice each input x value only goes to a unique output. And so this is definitely a function. No two ordered pairs have the same first coordinate and different second coordinates. The domain, again, the x values, and the range, the y values. Look at one more. This one's kind of funny because notice all the outputs are 3s, but each input is still, okay, so no two ordered pairs have the same first coordinate, so that's not -5 for each one of these, and we can see our domain, the x values, and then our range, the y values. So always think of your domain as your input and your range, your output. Where you have been solving equations where we have y equals, we now simply change y to this notation, red, f of x, where f of x is your y, your range, your output, and x is what you're actually inputting. So if we're given this function, f of x equals 2x squared minus x plus 3, and we're asked to evaluate it at f of 0, that means everywhere you see an x, you simply plug in 0. If you want to find f of -7, everywhere you see an x, you plug in -7. We can even do this with variables. If I said find f of 5a, everywhere you see an x, notice we plug in 5a, so you can even end up with something at the end with variables still in it. I can plug in even more than one term, such as a minus 4. So I've plugged in everywhere I see x, a minus 4. Don't forget to FOIL square this out. It's a minus 4 times a minus 4. And then once again, I can go through, collect like terms to get my final evaluation. All right, how we graph functions, same way as you did with the x and y, just our f of x is our y value. So you simply pick a value for x and you plug into your function. So if I plug in -3, that'll be -3 squared, 9 minus 5, and that's how we get the 4. So we now, instead of an xy point, we now have an f of x. So again, f of x is y. but in this case we call it a function because this is an output based on our x as an input. Another way you can tell that if you have a function, besides what we did at the beginning, you can do this vertical line test. If you can make a vertical line that goes through only one spot of the function. So yes, that's a function. No, I think this one's hitting 1, 2, 3 times. And I don't think this is a function either. It's hitting twice. Circle, definitely does not pass the vertical line tests. These two actually do. You'll learn about piecewise functions here in a few weeks, but in this case, this is an actual function. So it says when a function f whose inputs and outputs are real numbers is given by a formula, the domain is again the inputs, where we have to be careful with domains because I always say they're like good inputs. Like let's take this function for example. Can you plug in, say 1? Sure, I could plug in 1, and 1 minus 3, I get -2, or my function's negative, so f of 1 is defined in the domain of my function. Well, what if I wanted to plug in 3? If I plug in a 3, I get 3 minus 3, and bad things happen. We cannot divide by 0. So f of 3 does not exist. We cannot use 3 as an input in this function. Sometimes you have to do a little crazy stuff where in this case you might, you could set if I set this equal to 0, okay, what it cannot equal. And in this case, you're going to have to do a little bit of factoring. Remember how we love factoring. If x plus 3 equals 0 or if x minus 1 equals 0, bad things are going to happen. So if I solve this for x, I get -3 and I get 1. If I plug in either -3 or 1, I'm going to get a 0. So the domain consists of the set of all real numbers except those two values. And as I mentioned before, domain, we like to call this our inputs. These are the good x values, and the range are output. These are what we get out, our f of x, when we evaluate it at a particular x input.